Today we're on the Chapter 5 Chemistry 1 packet, and we're going to begin our discussion of electrons in atoms. We're going to begin by considering a wave, and all light travels in waves. So we're going to understand different parts of a wave. The top of the wave is called the crest. The bottom of the wave is called a trough. This is similar to the thing that animals drink out of. It's called a trough, like farm animals. If you were to take the distance between a crest to another crest, that would be called the wavelength. The symbol for wavelength is the Greek symbol lambda. So a lambda looks like that. So when you want to make a lambda, it's kind of like a upside down Y backwards to this effect. That's a lambda. That's the distance between two corresponding parts of a wave. It could be a crest to a crest. It could be a trough to a trough. It could be like the middle of the rise to the middle of the rise. Anywhere that you go that corresponds is going to be the wavelength. The frequency is how frequently the waves go by. That's like a sideways V blowing in the wind. That's frequency. It's called nu. The name of that is nu. So wavelength tells you the meters per cycle. How long is one wave? How many meters is it from one portion of a wave to the corresponding next portion of a wave? Versus the frequency is telling you how frequently they go by. Do you have 10 waves go by per second, 100 waves go by per second, that kind of thing. We're not really going to talk a lot about period, but period is the seconds per cycle, so it's the inverse of this. So if you had 2 cycles per second, 2 waves per second, then that means you have half a second per wave. That's all it is. Okay, if we look at units, the meters per cycle is the units of wavelength, and the cycles per second is the unit of frequency. Now, if you take a look at these units and put them together and multiply them, you'll see that meters per cycle times cycles per second, the cycles are going to divide out, and you're just going to get meters per second. This hopefully helps you to understand that the speed of light is equal to wavelength times frequency. I know it's a little confusing with these symbols, but if you want to draw, write in W and F for wavelength and frequency, that might help. And you're going to see that the units are going to match up with the speed of light, meters per second. Meters per second. So all light travels at 3 times 10 to the 8th meters per second. That's a very large number. Let's write it out. It's going to be 3 followed by 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 300 million meters per second. So if you snap your finger, that was 1 second. Light would travel 300 million meters. Now here's something that seems obvious, but this is always a trick question that kids fall prey to. All light travels at the speed of light. Any light is going to travel at this speed, 3 times 10 to the 8th meters per second, in a vacuum, technically. Okay, let's move this up and talk about the energy of waves. The energy of waves, if you have 2 different waves, I'll draw one and then the other. So here's red light. Red light has a fairly long wavelength, and blue light has a fairly short wavelength. If you were to look at 2 of these pictures, and one of them was a beach on a sunny day, calm day, and one was a beach day on a very stormy day, you would realize that the calm day is going to be the red, and the stormy day is going to be the blue. So the one that has more energy is the blue because it has more waves, versus the red, which has less energy in the wave. So energy is directly related to the frequency. The higher the frequency, like how frequently they go by, the higher the energy. But lower frequency means lower energy. So if you take a look at the units for this, there's a constant, which is called Planck's constant. It's h, and it's equal to 6.626 10 to the minus 34th joules times seconds. So if you look at those units, you're going to see that joules times seconds is going to be the h, and then 1 over seconds is the frequency. So let me explain what this 1 over seconds means. Very often, we don't include the cycles, all right? We don't write cycles in the units, which also means waves. We just leave it out. So you could simplify wavelength as simply meters, and you could simplify frequency as 1 over seconds. So 1 over seconds is the same thing as seconds to the minus 1, as you remember from your math classes. And there's also another unit called hertz, Hz, which stands for Hertz, hertz. That also means cycles per second, versus the meters is the wavelength unit. So again, if you're going to take your h, which is joules times seconds, and your frequency, which is 1 over seconds, you can see what's going to happen, that you're going to divide these out, and you're left with joules. So joules is the unit of energy, and meters per second is the unit of speed of light, and it's always a constant. So if we're going to take a look at these one more time, this is a constant right here, always, and this is a constant right here, always. Here's the value of h, here's the value of c, and all you have are variables now. The value of c is here, h is here, and here's are variables, wavelength, frequency, and then this is energy, and again this is frequency. It's the same unit and number that it would be for the top equation. These two match up. So if you had to do a problem, you could figure out any of the wavelengths and frequencies of light. If you know one, you'll know the other. So let's just take a quick example. Let's suppose that I have light that has a wavelength of 4 times 10 to the minus 7th meters. Okay, so I'll give you that information. So wavelength equals 4.0 times 10 to the minus 7th meters. And let's say I want to find the frequency. So wavelength times frequency equals speed of light. So I'm going to put the 4 times over here, negative 7th. I'm going to put the speed of light right here, 10 to the 8th, and that's meters. And then when I divide, I have to divide the 3 number by the 4 number. So 3 times 10 to the 8th divided by 4 times 10 to the minus 7th is going to give me 7.54 10 to the 14th. Sorry, 7.5, just 2 sig. It comes out to be 7.5. 7.5 times 10 to the 14th is going to be the frequency. That's 1 over seconds. Now let's suppose that I want to find the energy. So to find energy, you're always going to use E equals Planck's constant times frequency. Now we already found the frequency, so I'm just going to copy that down. 7.5 times 10 to the 14th, 1 over seconds. And then h is always 6.626 10 to the minus 34th joules times seconds. And that's going to give you an energy of 4.96, so we'll call that a 5.0 times 10 to the minus 19th joules. So wavelength, frequency, and energy are like a big puzzle. Okay, to sum it all up, the wavelength times the frequency equals the speed of light. So if you know one of them, you know the other one. Or if you know this one, you know that one. Now energy always has to do with frequency. So you have to know the frequency to find the energy. So a trick question is, like I gave you here, here's the wavelength, find the energy. First, wavelength finds you frequency, then you take that number and copy it here, times h gives you the energy.